Hey everyone, Coding Heaven here. Today's really exciting because we're gonna do our very first mathematical algorithm. Okay, the mathematical algorithm today is going to be factorial. Let's write that down. It's going to be factorial. Now, what is factorial? A lot of you are probably familiar with what factorial is, but I'll just explain it. If I say 5 factorial, for example, it's going to be 5 times 4 times 3 times 2 times 1. If I say 4 factorial, it's going to be 4 times 3 times 2 times 1. This, by the way, is equal to 120. This, I believe, is equal to 24. 3 factorial, 3 times 2 times 1, I think it's around 6. It is 6. 2 factorial, 2 times 1, and by definition 1 factorial 1. Now, you guys see the gist here. It's just the product of every single number which less than or equal to the number that we input here. So every single number less than or equal to this number, the sum of all those, the product of every single number less than or equal to 5 in this case. And in this case, it's going to be the product of every single number less than or equal to 4. And yeah, same thing for all the rest. Now, this way of doing factorial, we call it an iterative method. An iterative method is basically a process that you want to calculate something with a repeated cycle of operations. Like you use a bunch, you repeat an operation several times to get the answer. And if I say the words cycle of operations, what do you guys think of? Because we're programmers on this channel, right? This is Coding Heaven. So when we say cycle of operations, what is it that we think of? We think of for loops. Or while loops, but in this case, it's a for loop. In this case here, because we have a determined amount of loops, of cycles we have. Let me redefine factorial algebraically with n. It could be n times n minus 1 times n minus 2 times n minus 3 and times 1. This is factorial right here. This is the algebraic definition of iterative factorial. Remember, iterative factorial means a cycle of operations. Next video, we'll probably be doing recursive factorial. Recursive factorial is basically defining factorial with factorial. I'll be going further. That's why there's a whole video dedicated for factorial alone. I'll be going further with it, and it's gonna be awesome. I love recursive factorial. It's much more interesting than iterative factorial. So we have this. Now, what do we do with this? We code this. That's it. We code it for loop. We just code it. It's very simple. It's actually literally one line in a for loop. Let's get into it. Let's get into Eclipse. See you there. Okay, so we're here in Eclipse. What I'm gonna start by doing is creating like a whole new project for the functions I'm gonna start doing. So the functions I'm probably gonna start doing, wait, let's just create a project. Like I'm probably gonna create store all the functions that I'm gonna do, like the mathematical functions and everything, in one project. So we're gonna call, wait, no, it's the Java project that I want. We're gonna call it functions. Finish. We're gonna create a package. We're gonna call probably math. In that package, what we're gonna do is we're gonna first create a JFrame. We're gonna call it tester. It's where we're probably gonna input our we're gonna let the user input the values, and we're gonna put a button to press and calculate. This is for all the mathematical algorithms we're going to do. We're going to put it in the same exact template. Let's wait till it parses the page and everything. Taking longer than I thought. Okay then. What's up? Okay. Afterwards, we're gonna create a whole new class for Fibonacci. I have Factorial, Fibonacci. We're gonna create different classes like Factorial calculator, and in the Factorial calculator, we'll probably have around three functions. Three functions, three videos. First function, iterative factorial. Second function, recursive factorial. Third function, factorial, very big numbers that can be stored in a computer's integer. And the reason the fact that it can be stored in a computer's integer, we're probably gonna have to use strings to do that. Now let's add an absolute layout to our thing. Let's add a text field. Let's make it as big as the window. By the way, let's make the window 300 by 300. I like it a square. Text field, we're gonna call it input, because that makes sense. What the hell happened? Okay. Oh yeah. Okay. We're also gonna add a button. It's gonna be a button. We're gonna call it button calc, which means calculate. How do you name it? I think you double press. Oh, there you go. Naming it. Let's make it caps. Calculate. And in here, we're gonna create a function called tester. Let's call it test. And of course, we need to create that function down here. Public void test. And here's where we're gonna test our classes and functions. Easy enough. Oh, I didn't write functions properly. I always do spelling mistakes in my videos. I don't know why. So that's up. That's done. We need to add of course, generate and serialize, whatever. No one cares really. And remove unused import. Okay. That's done for tester. Now let's create another class and let's call it Factorial. Oh my god. Factorial calculate. Oh my god, I keep on calculate. Factorial calculator. Okay. That is done. We don't need it's gonna be a static function. We don't need a constructor. Okay, so public static int, it's gonna return an int. Oh, actually, no, long, because like Factorial has it increases very quickly, very quickly. In fact, I'll be seeing that when we test. Of course, we're gonna take a integer as a parameter because like alone the factorial of 10 is like already in the millions, I think. So that's dangerous. That's dangerous. So let's start. Let's create a long result. Let's set it equal to 1 at first, and then in the end return result. Okay, what's up? What are we doing here now? Like, remember what I told you, that it's a for loop. So what do you want to do is you want to do it backwards. If I put n equals 5, if I put n as an input equals 5, you're gonna do 2 times. We're gonna skip 1, by the way, because it's already here. So we're gonna do 2 times 3 times 4 times 5. If I put 6, we're gonna 2 times 3 times 4 times 5 times 6. If I put what number did I choose? If I put 6, yeah, we're gonna do that. But 7 is gonna do the same thing. So basically, you want to iterate between 2 to n, and you want to multiply the result that we get by it after each iteration. So let's start that. For int I equals 2, we're gonna start at 2, remember, and int I equals 2, I has to be less than or less less than or equal to n and I plus plus because it's our iterator. And then in here, like I said, we're going to do result equals result times I. That's it. We're done. That's it. This can be compressed to result times equals I. But for case of like comprehension, I do this because it's way more clear and everything. It's like much more clear. Okay, done. We're done. So let's test it out. Let's do this. Let's take let's do string like sn equals input input dot get text, because I remember that we have a input text box, so like we need to get the text, and then int n equals integer dot parse int, and then we need to write sn. So this is going to get our integer. Now what we're going to do with the integer is we are going to access the factorial calculator dot iterative factorial, and we're going to put n right there. Okay, done. Oh, sorry, we're going to store that in a variable, sorry, int res equals this. Why is it red? Oh, I need to import it, right? Cast to int. Oh, no, sorry. Long, there you go, now it works. And we are gonna j option, we're gonna make like a message box, and we're gonna put the answer. I'll probably implement like a, what do you call it, like something to like something to put it, like to put it on the, actually let me do it right now, actually. J label, slap it in the middle. Let's make it big. Let's make it centered. Center. Horizontal alignment. Center. Let's call it output. It's very like it's the most basic thing to call it. New label. Oh no, it's supposed to, output is supposed to be, oh wait, oh no, here's supposed to be written nothing. Sorry. That is the that's the text that's written on the label. At the start, I don't want to write it there. Okay, so now what we're gonna do is we are going to no, what do we do? We are going to I'll put it output dot set. Wait, what's the name of the thing? Output dot set text. Wait, why is it wrong? Okay, so I cut there, and like it was a very simple problem. Actually, like this was supposed to be it was supposed to be initialized up here for it to be global. That was such a, it was a new mistake, but it wasn't even me that did it really. So let's do this. So it's gonna be integer dot to string, and we're gonna put, oh no, sorry, long dot to string, and we're gonna put res in here. And done. Now let's run. So put 5 in here. Remember I said it was 120? There you go, 120. Put put like, I don't know, 10. Like I told you guys, 10 is really, it's pretty big. That is 3 million. And if you put a 100, done. The computer isn't able to calculate it. It's way too big. So see, let's try the difference. You see the difference between 10 and 15? It's huge. That's 10 and 11. The difference is big too. This is already like it's already in the tens of millions. It gets very, very big very quickly. Like 2, 5, and then just 10 is just boosts up. Okay. Anyways, thanks guys for watching. Subscribe if you're interested in these type of videos. I'll be doing recursive factorial next video. So yeah, thank you for watching. Like and subscribe. See you next time.